Good afternoon. Today we're going to continue our discussion on portfolio optimization. Okay, so last time we were using this file and we loaded these packages, quant mode, performance analytics, performance, portfolio analytics. Although quant mode, we will not be using that much today for downloading stock prices. Sorry. I was thinking of your case. Yes, we're going to use this. So let me just let me first clean. Okay, let me clean my environment. Okay, so I'll load first the packages. Oh, sorry, I clicked the wrong. Okay, and then let me define the start date and the end date. Okay, and the tickers there. And then let me go below to, we were using the QMAO package. There's this function called PF and RF, but let me first load the ticker symbols under the tickers object. So let me load that. So I now have the time series for the 6 objects there. Okay, dalang klase. Okay, so there seems to be something wrong here. Unable to import IBM. Okay, let me redo this. So, I'm sorry about that. Bakit kaya hindi nag-load si IBM? Okay, so let me load again this one. IBM, yeah, it's correctly spelled. Okay, let me load this again. And let me go here. So this one. Okay, so this is to get the symbols. We know that this will get the XTS objects there. Okay, why? IBM 1, 2, 3, 4, 5. Why isn't it loading? Okay, let me just. Is it the same date? 2023, 2018, 0101. Okay, let me rerun this class. Sorry, I don't know what's happening to this one. Okay, so I think I rewrote it here. All right, IBM, BAC. Okay, tickers. Okay, let me just run this individually. Okay, so which means that I should have a vector here. Okay, so here is my vector. IBM BAC, okay. And let me redefine again my start date and end date. Enter. And then I'm going to use the get symbols function from quant mode. Tickers from is equal to start, to is equal to end, okay. Daily, okay. Okay, there you go. All right. Yeah, I have it now. Double check. There is IBM. Okay, so I hope you didn't encounter the same challenge. So let me now use the PF function, PF okay, price frame. So this will generate now a frame, okay, one data set called PF, which contains adjusted prices of all the six assets, six stocks. Okay, so I viewed it also. So there you go, IBM, BAC, etc. Okay, and then I'll also run the RF, the return frame there, RF. So this is RF and a.omit to delete the first line because the returns, the log returns will have an NA or a 000 value in the first line. Okay, so now this is our returns. Okay, with 1508 observations, while the the PF has 1509, I think. Yeah, 1509 observations compared to the RF, which has 1508 observations. And you know why. Okay, so what we did last time was we started with we just choose we used a portfolio with two assets. Okay, we said that we created this one port one object, which has sorry, here port one object or port object, yeah, port one object. Okay, and it's the return frame, and then we're only including the first and the second one because our example was only a two asset portfolio of IBM and Bank of America. Okay, so we now have this one, and this is port one containing only IBM and BAC. Okay, this is just a quick review class. We have already discussed this. Okay, so we can create a portfolio of 50-50. Okay, that's very easy. We have already discussed this. So if we create a portfolio of 50-50, then we can make use of the return that portfolio function. Okay, and then we identify the weights. It's a 0.5 portfolio, 50-50%. Okay, so we already did that before, so I'm not going to redo that. So we will now go to our portfolio optimization, okay, steps. So the steps in doing portfolio optimization, as we said, is first define the portfolio returns to be optimized. So we need to really identify or define what is that object that we want to be optimized. Okay, and then we have to add the constraints, add the objective, and then optimize a portfolio, and then extract the weights, and then create some charts and tables that will give us more information about the portfolio. Okay, so we're going to make use of portfolio analytics and port one class. What's port one? Port one is the asset. This is the returns of IBM and BAC. Okay, so we're going to use that. We're going to create a portfolio optimization using port one, which contains the returns of IBM and Bank of America. Okay, so the first step is create a container object. Okay, a container object where we will load all the specifications, the constraints, the objectives. We're going to load it there. Okay, and the way to do that is to create this container via the portfolios.spec function. Okay. So we did this last time class. We used the portfolio.spec function. Okay, and then created this object, this container. Okay, and we defined the assets to be equal to the call names of port one. Port one only contains IBM and BAC. Okay, so if I run this, so port spec one is simply, okay, it's a list. Let's port spec 1, it's a list of 6. So this summarizes the so let me just sorry class. Port spec 1, and then the assets are identified here. IBM and Bank of America, it's 50-50. Okay, 50-50. Did we define that to be 50-50? Okay, no, it's the default. It's defaulted to be 50-50. Okay, because port 1 it's an XTS object containing the returns of IBM and BAC. Okay, and then as I said, we haven't defined yet the weight sequence, the constraints, objectives. We haven't defined that yet, so we will go into that now. All right. So last time we did this already, di ba? Itong add the constraints. So ang function yan, add that constraints. By the way, this is coming from the portfolio analytics package. Okay, so we define the syntax is define the portfolio, and the portfolio is the container that we created, port spec 1. And then we define the type. Okay, we discussed this last time. Full investment means, okay, what does it mean? The minimum, okay, the minimum sum of the weights is 1, and the maximum sum of the weights is equal to 1. Okay, so in other words, strictly the sum of the weights. Okay, because we have two assets, IBM and BAC, R will compute for the weight of IBM and the weight of BAC, and we're imposing strictly that that it should be 100%. So whatever the weight of IBM is, the weight of BAC will be 1 minus the weight of IBM. So it should be strictly, the sum should be strictly 100%. All right, so if we run this class, let's run this first, okay, so quickly. And then I'll go now to our port spec. As I said, this is our optimization container. You can now see here that under the constraints, okay, under the constraints, we have here weight sum constraint, okay? If I click this, okay, there you go. So that's what is meant by full investment. Full investment means the minimum sum. If you add the weights, it should be 1, and then the maximum of that is 1. Okay, so very strict that the sum should be 100%. Okay, let me pause for a while, class. Any questions about this full investment? Okay, let me rephrase my question. Are we clear so far? Are we clear so far? Okay, good, good, thank you. Okay. Okay. Remember, the objective here is to create a portfolio that will, depending on the objective. So we can create a portfolio that will minimize the risk, or create a portfolio that will maximize the return. So when we say create the portfolio, we will have to assign weights to the different assets. And our example now is quite simple because we're just using a 2-asset portfolio. Okay. So we can add more constraints. Okay, so port spec, add that constraint. So you can have several constraints. Okay, and by way of review, class. Okay, did I don't think so. Okay, let me see, class. Okay, for more information about this, add that constraint in our. Okay, okay, we can use this R documentation, or here data camp, or here. I'm not sure if I discussed this with you last time, but anyway, let me just share this with you. Or of course, you can also do your research on your own and look for other materials, other references that can help us, that can help you understand more about this. Let me put that here. So there are many references about this class, and this is just one of them. Okay, so if we take a look at this, add that constraint, then you have to define the portfolio first, okay, and then the type. Then we have here other uh, other functions, okay. So if you take a look at the definition, portfolio is an object of class portfolio. So this is our port spec one, okay. So this one, so it means that this portfolio should have been created under this one, portfolio.spec, which we created, right? And then the type, so there are different types. Character type of the constraint to add or update. Currently, we have weight sum, okay? Or this is also called leverage or weight. Then we have box, then group, then turnover, diversification, etc. So we have several functions here under the type in type. Then we have this enabling the default, and then some display message, etc. Index number if you're going to update a specific constraint. All right, so below here are more explanations. Okay. Full investment, this is what I mentioned to you a while ago. Full investment is a special case of weight sum, where you set the minimum sum is equal to 1 and the maximum sum is equal to 1. So if you're setting the minimum to be 100% and the maximum to be 100%, then it's a strict constraint that the sum should be 100%. Now, in optimization, this may or may not be a problem because the solution might not converge. Okay, so for example, if you want to minimize the risk, R might not be able to find a solution for minimum risk where the sum of the weight is exactly equal to 100. Okay, that's why we can relax this a bit, which I'm going to show you in a while. All right, so this is dollar neutral. Okay, so it's a special case also like food investment, where this time minimum sum is equal to 0 and maximum sum is equal to 0. This is the opposite of full investment. Okay, and then we have box constraint where you can identify. So if I click this, I'll open this in a new tab. For example, I want a particular asset to have, okay, I think my, uh, once you have the, by the way, once you have the data class, please PM me, okay? I'll just close this for a while because, okay, this one class, box that constraint. So you can, and usually it gives an example here. Okay, so for example, for this one, you have, this is making use of a data that's loaded in R, the EdHec data. Okay, and then here you see, first you create this portfolio.spec. So it's for P-spec, and then add that constraint, type is equal to box. Okay, and then here, add that constraint, P-spec also, type is equal to box. Okay, and then here, it's minimum is equal to 0.05 and maximum is equal to 0.45. If you don't, if you don't define this, the minimum will be 0 and the maximum will be 1, which means that an asset can have 0% and an asset can have also 100%. So that means that if you have 10 assets and you're allowing this type is equal to box, one asset there can have 100% weight, which means there will be no loading in the other assets. But you can also choose to minimize, put a certain level in the minimum and in the maximum. So this means 0.05, no asset will have a weight that's less than 0.05, and no asset will have a weight that's more than 45%. Okay? All right, so this one, you can specify the box constraint by asset. So here you have 4 assets. So you're saying that asset 1, and it's how it appears in your data. Okay, So that means you have four columns here, four returns of asset A, B, C, D. And here you're saying that the minimum for asset A should be 5%, for B it's 10%, for C it's 8%, for D it's 6%. And then their maximum should be 45, 55, 35, 65, respectively. Okay, so this is what the box constraint will give us. Okay, so going back here, okay, so there are other constraints here, and what's good about this one is that you can refer to this. Okay, you can refer to this. This will be helpful, class, for your case, for you to be aware of what this add that constraint is, and then you can also make use of this. Okay, you can create a portfolio in such a way that you make use of the diversification, for example, position limit, etc. So I leave you, class, to peruse over this and see how you can, in your creation of your portfolio, make use of the functionalities of the portfolio analytics, in particular the add that constraint. Okay, so let's go here. For our example, I just utilized first the full investment, and then the for the long only. Okay, so what's the long only, class? Let's go back here. Sorry. What does the long only? This one here. Okay, so it's a special case set to minimum is equal to 0 and maximum is equal to 1, which is similar to the box constraint. So box and long only are long only is a special case of the box constraint. So what does this mean? This means that any asset can have 0 weight. Okay, which means that you're not going to invest in that asset. And it means also maximum is equal to 1. As I said a while ago, it means that one asset can have all the weights. Okay, so it means that for your portfolio, 100% is allocated to that asset. Okay, and this happens usually when you have uh, just a one objective. For example, you just want to maximize the returns, and usually the asset which has the uh, greatest average returns would have 100% of the 100% of the weight. Of course, since you're maximizing the returns, and then since there's no constraint, box constraint as to the minimum and the maximum, the minimum is just 0 and the maximum is 1, which means that any asset there can have 100% weight. Okay? All right, so let me pause for a while. I've been talking a bit, and may I ask you, class, if we're clear on this so far, class, about this? You have this reference. The powerful thing about this is you can, on your own, learn about these things. Okay, good. Thank you once again for your feedback. Okay, let's now go back to our to this one. Okay, thank you. Now, the third one that we placed last time is again add that constraint, and you notice that the object is still port spec 1. So we, as I mentioned a while ago, we're just creating a container, and then we keep on adding or amending or updating that container. Our container is our portfolio. Okay, thank you. Thank you for your comments. All right, so here we have long only, which means this implies that the minimum per asset is 0, right? And the maximum per asset is equal to 1. Okay. However, when we add this one, type is equal to box. Okay, and as I said a while ago, this is also box, class, no? Type is equal to box, and minimum is equal to 0.1, and maximum is equal to 0.7. Okay, so even if you have a minimum 0 here, and then you have here a minimum is equal to 0.1, then this will prevail, class. Ito magpe-prevail yan. Even if we place this one, minimum is equal to 0, and then we place minimum is equal to 0.1. What will prevail is this one, okay? Because if an asset has, let's say, 0.05, what happens? what happens, class? It will still be okay for this one, right? Minimum zero, it's okay if it's a 5%, 0.05 weight. Okay, so this will not be invalidated. However, how about this constraint? This will be invalidated. Okay, so even if you put minimum is equal to 0, and at the same time minimum is equal to 0.1, there will be no conflict there, class. Both conditions will be met. Okay, so if it means that you cannot give the asset 0.05 weight because it will be okay for this one, but it will not be okay for this one, since we're setting that the weight should be minimum of 0.1. Okay, so I hope that's clear. There is no conflict in this constraint. Okay, let me once again pause for a while and ask you if that explanation is clear, because you might be thinking, how can this be? Can these two conditions exist? Yes, it can. There will be no conflict with that, even if we put minimum is equal to 0 and minimum is equal to 0.1. The rationale is both conditions have to be met. Okay, good. Thank you. Okay, this will come in handy, class, when you do your case. All right, so we have the box constraint here. Okay, so we can run this together, class, run. Although we have run this before. Okay, I won't run this again. I won't run this everything because I've already run this one. So I'll just run the second one and the third one. Okay, because if I run all the codes in this code chunk, then it will repeat this one. It will repeat the full investment. Okay, so let's now review our port spec. What's now inside our port spec? Okay, so you can now see that the constraints, there are 3 constraints now. Exactly what we loaded to the port spec 1 object. So here, the first one is weight sum constraint. This is the sum, right? And the sum, the minimum sum should be 100%. The maximum sum should be 100%. And then for the second one, you have here box constraint, okay? Minimum 0, maximum 100%. And another box constraint here, same box constraint class. Okay, but this one is more limiting in the sense that this is minimum 0.1 and maximum 0.7. And of course, just like in the example, we can also create a minimum and maximum, different minimum and different maximum for IBM and BAC. That can be done. Okay. Okay, let me just once again show you, class. Ito yung class, no? Add that constraint. Type is equal to box. Then minimum is equal to, then you have a vector there. Okay. Vector. So for example, you want the minimum for IBM to be 0.10 and for BAC to be 0.2, then you'll have to write 0.10 and 0.2. So there in that case, there's a different minimum for IBM and a different minimum for Bank of America. And also for the max, you can write here different figures for both of them. Okay, so I hope it's getting clearer now. Okay, I really wanted to review this because I know that when we were discussing this, I was going quite fast. Okay, and so I said we need to review this. Okay, so we now created the constraint. Okay, so we now go to the add that objective of the portfolio. Add that objective. Okay, let me share this with you again. Okay, now for the add that objective, which is this one, add that objective. Okay, so let me put this in the chat box and kindly copy this so that you can also refer to this. Okay, so this is in the documentation. Okay, Control B. This is also in the documentation. So very helpful, class. Portfolio Analytics version 1.1, add that objective. Okay, so this is the general interface for adding optimization objective. Okay, so you have risk objective. So this is for risk minimization. You have return objective, of course, for return maximization. And then if you're creating a risk budget, okay, So there are three types of risk there, and you can also have combinations of risk and return. Okay, so what's the syntax? This is the general syntax. And then we go here, the details. Okay, so we're told here that for the type, okay, you have return, you have risk budget, you even have quadratic utility or weight concentration. And it's all explained here, class. Okay, it's all explained here. So, sa type, for example, in general, you will define your objective as the following: yan, return, risk budget, quadratic utility, weight concentration. These have special meaning and intelligent defaults in dealing with the function, most likely used as objectives, including mean, median, value at risk, expected shortfall, etc. So ito, plus I'm not sure if you have discussed expected shortfall. So maybe we'll also discuss this in this topic so that we know what value at risk means and also expected shortfall. So may I ask class for your feedback? Have you discussed VAR and ES, expected shortfall, in your previous subjects? Most probably VAR. No? Class feedback, please. Value at risk. Okay, thank you, Eliza. How about the others? How about ES, expected shortfall? Okay, only VAR. Okay, good, good. Maybe we'll have an example where we discuss VAR and also expected shortfall. Okay, to be honest with you, class, I'm excited to really complete this, finish this, so that you can work already on your case. And of course, even if we are not able to finish this class today, the discussion, because there might be some other details that we need to look into. Okay, I expect you to be able to already start the case. Okay, kasi sa start ng case naman, class, yung pag-clean ng data, etc. Okay, so there should be no concern, class. Okay, so for example, this is an example here. This is for quadratic utility. Okay, so this is something to do with penalizing the variance, the risk of the asset. Okay, the two most basic ones are this one. Okay, add that to objective. Again, you'll be using the container. Okay, type is equal to return, name is equal to mean. And then you have here, type is equal to risk, name is equal to standard deviation. Okay, then you can use here, type is equal to risk, and then you have your expected shortfall. Okay, then you can have here your type is equal to risk budget, and then also use the expected shortfall. Okay, there's no example here of value at risk, but I'm sure you'll be able to see other examples in the internet. Maraming examples, class. All right, so the first thing that we did last time was just to, okay, we had a simple example only. And our example was to, here, type is equal to risk, and then name is equal to standard deviation. Now, I did something last time. I hope you understood this. We have already this port spec. The port spec one includes of course, the specification and the constraint. Okay, now I'm going to preserve that, the specification with the constraint, and then I'm going to add an objective. So I'm going to create now this object, portfolio minimum variance 1, and it will be the same as port spec 1. I'm doing this so that I'm able to preserve yung port spec 1 object, so that later, if I have another object na return at saka mean, di ba sabi natin, class, for the add dot objective, you can have yung risk, you can have your return, okay? You can have the risk budget, you can have the quadratic utility. So there are several examples of risk that you can do here. And I strongly urge you, I strongly encourage you to experiment, okay, to look at the different examples. So for our first one, we're just making use of the minimize risk, okay? Type is equal to risk, and then name is equal to standard deviation. Of course, it's understood that the objective here is to minimize the risk, okay? That's a default. Of course, nobody would want to maximize the risk. All right, so let's create this. I think we have created this last time, okay? All right, so now this is port min var. Okay, so port min var, okay, has the uh, specification of your port spec. Okay, so you have here your asset 0.5 as of now. Then you have the constraints, 3 constraints. And then if you take a look at objectives here, okay, one objective. And what's the objective here? Our objective is, okay, it's standard deviation. Okay, let me see the arguments here. Enable is equal to true. Okay. All right, so the formula that we use is add that objective, type is equal to risk, and then standard deviation. Okay, so we're now, you can now, I hope you now appreciate what's happening to our container, okay? Port spec 1 is still here, okay? Let me just show you, okay, here. There's no objective here. I'm preserving this object so that later on, if I create another objective, which is to the return, okay, the mean, then I can still use port spec 1, so that I'm able to preserve all the initial specifications we gave here. Okay, so so I have a question here. What if we are maximizing resource? Then type is equal to return. Name is equal to mean. Ganun lang, no? Type is equal to return and name is equal to mean. So that's how easy it is to look for a, let's try to do that in a while. All right, so that's the answer here. What if we're trying to maximize returns? All right, then next, okay, next is optimize, okay? Optimize a portfolio. All right, so let me again, Control C, share this with you, class. Again, documentation is very important. You can learn a lot from that. You can be guided by that. So that's one good thing about the packages in R. You're not left alone, okay? And if it's quite hard to understand, they give examples. Okay, let me close this and just open this one. This is the objective there. Okay, so what's this all about, class? What's our objective? Oh, sorry, not objective, but optimize that portfolio. Okay, this is, let's say, this is, ito yung medyo mas technical class, no? Kasi as I said a while ago, okay, for the objective, okay, so what are we doing here? This function aims to provide a wrapper. So when we say wrapper, it will complete now the portfolio optimization that we were doing. Okay, a wrapper for constrained optimization of portfolios to specify the constraints and objectives. Okay, so we identify the constraints, we identify the objectives, and then we now optimize that portfolio. It's down the wrapper. Okay. All right. So if you take a look at this, what's the syntax? You have the R object, which is an XS vector, etc. Okay, they optimize that method. So you have here several methods, no? Okay, this is DE optimization, random, ROI, ROI old, PSO, general algorithm. What's this? I forget the S here, but this is something to do with algorithms. Okay, the default is search size is equal to 20,000. So what R will do is that it will create, in this case, 20,000 portfolios. Okay, 20,000 portfolios. So which means that it will create, since we have two assets, we have weight 1 and weight 2. Okay, so you have 20,000 weight 1 and 20,000 weight 2. And then it should comply with the constraint. For example, whatever weight 1 is, for example, it's 0.3, then weight 2 should be 6.7 because the sum should be 100% because of the constraint of food investment. Okay, but it will generate. Okay, it will generate 20 in this case if we don't identify this. That's the default. Or you can make it search underscore size and you can make it 100,000. Okay, so it will generate 100,000 different portfolios, and it will try to find what is the minimum risk of that set of portfolios. All right. So once again, I leave you guys to look at this one and look at the syntax. Okay. Is there an example here? Okay. Unfortunately, no example. Okay, but there are some details here which I want you to and there are some instructions here, for example. No? Okay, so let's just take a look at some of them. This function currently supports DE optimization, what we mentioned a while ago, additional backend contributions for R metrics, G hype, etc. When using random portfolios, because you can make use of random here. Search size is precisely that. Okay, how many portfolios to test? So this is needed, especially when you're using random. You need to make sure to set your feasible weights in generate sequence to make sure you have search size. Excuse me, class. No? All right, sorry about that. So I leave you class to read on this. Okay, so let's just go back to what we were discussing a while ago. So the fourth step now is to define the uh, optimize the portfolio. We have defined the objective. Sorry again. Okay, apologies for that, class. All right, so here, okay, so I don't think I've shared this with you before. Okay, so let's take a look at this class for the fourth step. Okay, remember our objective is to minimize risk. So the next step is to optimize now our portfolio. Remember that this function is a wrapper. It will now complete the container. So our R is port 1. Okay. What is port 1? What's port 1, class? Port 1 contains the returns. The returns of all, okay. Sorry, port 1 contains the returns of IBM and Bank of America. Okay. And our portfolio is port min var, the one that the container that we created, this one, the one with the constraints and the objectives. Okay, so this identifies our XTS object, the one with the returns. Our portfolio is the one that's with the container, with the constraint, and with the objective. And let's use the optimize method, and let's use random. So this means that search.size underscore size is default at 20,000. You can, of course, change this. Let's say 50,000. Okay, and then what will happen is that R will generate 50 portfolios. Okay, 50 portfolios. And then set.seed, we can use set.seed a number so that we have the same the same randomization random weights. Okay. Okay, set.seed to a number. I'm just using 111 here. And then let's run this class. Okay, let's change this to 50,000, for example, and then run this. And then let's see what happens. So it's now generating portfolios of 50,000. So different portfolios. And when we say portfolios, it means different weights, okay? And there are constraints about that. We have the full investment, which means the sum of the weights should be 100%. So it's still running. It will take quite some time. Not really that long, because it's trying to generate 50,000 portfolios, and then it will try to determine which of these portfolios will generate the minimum risk. Okay, anybody who has an answer already, class? I should have used 20,000. Medyo tumagal, no? Okay. Okay, so maybe I'll escape this. Okay. Okay, let me class just use 20,000 because it's taking quite some time. Okay. Let me run that again. And then notice. Okay, I hope it consummates the code. How about in your case, class? Who among you have had answers already? And can you please copy paste the answer here in the chat box? Anyone who has generated an answer already? Okay, there. Still loading. Okay, in my case, which most probably in your case also, take a look at this message. Leverage constraint, which is the minimum sum and maximum sum, are restrictive. Take note, class, the leverage constraint that we did is the full investment. Okay, the full investment, we set it to be, we set that to be full investment, which means minimum sum is 100%, maximum sum is 100%. Okay, so as I said a while ago, class, this can be quite restrictive. So for it may be good to relax that full investment a bit, okay, by using this 0.99 minimum and maximum 1.01. Okay. So how do we do that, class? Okay, so please copy step 2. Where's step 2? Copy it. This one. Okay, this one, class, where we added the constraints. Kay Eliza nag-load, no? Okay. Kay Eliza, nag-load the answer. Could you kindly, let me stop share. Eliza, could you kindly share your screen, please? So sa kanya
Sir, I'll just change my device.
Sorry? Okay, sige. How about for the others, class? Can you please give your feedback sa chat box? Did you get the same message as mine? Masyadong restrictive yung full investment natin. Yung minimum sum is 100%, maximum sum is also 100%. Did you get the same message? Feedback, please, class. Okay, thank you. Sherry, for Sherry, it's the same. Oh, ganun din, no? Eliza, ito din, no? So, I think everybody will get the same message. So, kindly go back, Eliza, to the to the RMD file. There, sa ilalim, the red one. Leverage constraint, minimum sum and maximum sum are restrictive. Okay? Consider relaxing daw, sabi nito. So hindi siya hindi siya nag-converge sa solution. Wala siya nakitang solution, okay? Ang sabi niya, full investment constraint, we could replace this, no? With minimum sum, gawin natin 0.99 and maximum sum 1.01. So we can have a portfolio where the sum is 99% or the sum is also 101%. Okay? So thank you, Eliza. Okay, let me share my screen again. So let's go back to let me go back here to my example. How about the rest? Same message. Okay, thank you. All right, thank you. Okay, thank you, Nathan. Thank you, Cherie. Thank you, Chloe. Okay, same result. Okay, so as I said, kindly copy this step 2 and paste it here below. Okay, please preserve the original one, class, so that you can when you're reviewing, you know where it came from. So here, okay, type is equal to weight sum. Okay, so that's the type there. It's not the same as box or long only. For the type long only or for the type box, what you're doing is limiting the weight per asset. Here, it's limiting the sum. So we can change the type is equal to full investment to this one. Type is equal to weight underscore sum, and then minimum sum is 0.99, maximum sum is 1.01. And then same thing for the other two, for the type long only and for the box. All right. And once you have done that, class, let's run again. Okay. Let's run this again. Okay. So we have run that. And then let's go back to that step 2. Let's go back to step 3 here. Let's rerun step 3. Okay. Take note that we now have a different okay, we now have a different port spec 1. Okay, so let me just show that here. Port spec 1. Our constraints are now, okay, sorry. Now take note, class, when we run port spec 1, naging 6 na yung constraint, ano? Because a while ago, sandali lang ha. Ito yung port spec 1 natin. It already had 3. Okay, it already had 3 constraints. Okay, now, since we run port spec 1 again and then run the constraint again, then there are now 6. Parang nagdoble na. No? Nagdoble na siya. But that's okay kasi again may limit tayo dun sa ano no dun sa yung 4 natin is yung minimum weight ito no 0.99 at saka 1.01. So even if may ano doon may merong 1 yung full investment, ang magpe-prevail pa rin, class, yung ito. Okay? So no problem. You might ask, but we have a constraint there, the full investment. And then we added this, the minimum sum and the maximum sum. It's okay. Okay, because what will prevail is the 0.99 and the 1.01. All right. So let's now do this. Okay. Right, so let me run. We have done step 2. And then we have to rerun step 3. Okay. We have to run now the add that objective, okay, with a different port spec now. So let's run this. Okay. And then also the step 4. This one, the optimized portfolio. This one, let's run this again. Okay. There. Let's wait for it to generate the answer. Let me pause for a while, pause recording. I'm sorry. All right. So what have we done so far? We have run the portfolio.spec. We have run the add constraint. We have run the add objective. And after running the add objective, we run the optimize portfolio. Okay. So let me just finish discussing this class. So after we have done that, okay, we were able to generate this minimum variance optimal solution. Okay, so if I click that min var opt1, so it's a list of 8. Okay, as you can see here, now you can see here, class, that we have here 1, 2, 3, 4, 5, 6, 7, 8 objects, class, because this one weights has 2. Okay, or wait, 1, 2, 3, 4, 5, 6, 7. List of 8. Okay, first we have here the weights. All right, so you can now see here that IBM has 0.7 and Bank of America has 0.99, and the sum of this is 0.99. So this is telling us if you want to minimize the risk, you have to load 70% of your assets to IBM and 29% to 29% to Bank of America. Okay, objective measures. We know that this is standard deviation, and the standard deviation is 1.595%. Okay, optimal values here. Okay, so it's the standard deviation that was optimized, in particular minimized. So this is the minimum risk, and then this is the formula. Okay, 20,000 uh, 20,000 randomly generated weights, random method. Okay, optimized portfolio, and the portfolio here, it tells us the assets, the constraints, the objectives, the one that we did a while ago. And here, data summary, click this. Okay, what do we have here? What's this? First and last. What do we have here? These are the returns. Given this weight of 0.7 and 0.29, these are the daily returns of the portfolio. Okay, so let's go back here, class. And okay, so this one we already did. We viewed this one, min var opt, and the names under min var opt. So these are the names there: weights, objective measures, optimal values, the formula they call portfolio, data summary, elapsed time, and end time. Okay, so let's now, let me share this codes with you. Fifth class, let's now extract, although we have seen that already. We have seen that in the min var opt. Okay, so we can extract the weights of min var opt. Okay, and there are several ways to do that. Okay, so extract the weights min var opt, that one. So it's telling us that IBM should have 70% and 29% so that your risk will be minimized. A minimized risk 70, 29. Or you can use this min var opt, and since we know weights is an object there, that you can, this will give the same answer. Okay, and then let's extract the objective measures this time. What are the objective measures? The objective is to minimize risk, and we expect this to be 0.015 something there. Okay, the measure is The one that we're optimizing is the standard deviation, and the measure is 1.59%. Okay, and then you can also get this from mean var opt1, and then $ objective measures. Let's run this. Same thing. Okay. Now, we can, of course, since it's only a two asset portfolio, the weights will be just two weights, okay? The 70% and the 29%. So I'll just share this with you, but just write the chart weights. Chat. Okay, so what will this give us, class? I can't I can't uh, I can't run any query, class, because nasa na yung query ko? Okay, this one. Okay, I'm having internal server error. So kindly, or we can, of course, we can go to Google and then chart that weights. What does this give us? It will just give us the plot. Okay, there, same thing. Chart that weights. Okay, so this function charts the optimal weights of a portfolio. We use this to optimize that portfolio, right? And this one, okay, take note, class, that in your case, you're asked to do optimize rebalancing. So this is where it comes in, class. Optimize that portfolio rebalancing. This one does not rebalance. This one, if you're going to rebalance. So just Control C and then share that with you. Okay. All right. So let's just run that, class, quickly. It's just a short code anyway. All right, here. So you can use this, chart that weights, and then the object is mean var opt1. I'm not going to share this with you, just type it, and plot that type is equal to bar. Okay, so if we want the bar chart for that, okay, then it will just give us the plot of your IBM, and this is 70%, and then your your Bank of America at around 29%. Okay, pretty straightforward. Then I can give this to you. I'll just share this with you. Okay, so this is a more detailed, but it will just give us the same thing. Two boxes, and then okay, ito lang, class, no, yung color set. You can get this from Microsoft Color. Okay, these are the Microsoft Colors code, and if you run this, okay, of course you have here main is equal to, that's the main title, and then axis is equal to 1, that should be in the center. Label of x-axis is stock, center it, okay, center the label, and then element color is gray, etc. Legend, that location is at top right. Okay, if you run this, same thing. Okay, my legend siya dito sa top right, class. There, my legend siya dito, no? And then the colors are quite different from the default. Yes, Eliza, any question?
Sir, sorry, can I see the code jump before that?
This one, okay. Ito,
Thank you, sir.
simple lang siya. Chart that weights, no? Then plot that type is equal to bar. Okay, so okay, let me. You can of course experiment, class. Just type Microsoft Colors, and it will give you different codes for the different types of colors. All right. So I think we'll be able to Okay pa tayo dito, no? Now, before we finish our discussion, I'd like you to experiment class, okay? Now, create now the portfolio of the 6 assets. And then create now the port spec. You can name it, of course, differently. And then run it using uh, changing the objective to be minimize the risk, and another by maximizing the returns. But that's very easy. I told you how to do it already. And you'll see that it will generate, it will give different solutions. Okay? Kasi iba yung minimize risk and maximize returns. And then you have 6 assets yung sa ano natin, yung sa first object natin, 6 assets yan. Then you can vary the constraints. For example, you want that each asset should have a maximum of how many percent and a minimum of how many percent. You can do that. Okay, and try to see if indeed the constraints are followed. All right, I think this will be our last code for today. Let me just share this with you. Okay, so let's take a look at this class. Okay, so here I'm creating this object minimum variance perform 1. So I'm using this return that portfolio. This is to create the return class, the return of the portfolio, where your R is equal to our port 1. This is the return of IBM and BAC. And then the weights that we're going to use is extract weights from min var opt1. So you recall, class, that the weights coming from the min var opt1 is 70% and 29%. Okay, so we're defining the weights to be 70, 29. So it will compute for the returns, okay, on a daily basis because our port 1 is daily. Okay, so if I run this, it will now yield this one. So this is now the returns for January 3, 2018, where the weight is 70% IBM and 29% Bank of America. Yun, daily return siya, no? Hanggang dulo. There. Okay, so they're all returns. Okay, and then we can plot this one. We can use the charts, that performance summary of min var perform 1, this one. Okay, so if I run this will now be our plot. You have the cumulative return, the daily return, and the, okay, so 3 things here, class. Cumulative return, so it just adds the returns, daily returns, keeps on adding, keeps add every day, cumulative. Okay, so you can see it started here and it ended here. If you keep on adding the returns, this one is your daily returns. And I'll leave you, class, to explore what is drawdown. Ano ibig sabihin ng pag nagdo-drawdown, class? So it's linked to this one, of course, linked to these returns. Okay, and do you notice a pattern, class? Pattern of the drawdown. What does it follow, class? You notice how similar it is to your cumulative returns, di ba? Tingnan nyo, class. Oh. Minimimic niya yung cumulative returns, no? But there's a definition for drawdown, and I want you to please find out what that is. Okay, how are drawdowns computed? Pareho ba lang ba yan ng ano ng cumulative returns? Okay, so kindly find out kung ano ibig sabihin ng drawdown. All right, so let's end there, class. As your assignment, I'm not going to collect it, but please experiment. Use the six assets. Pag nagawa niyo yung class, yung case yung madali na eh. Kasi halos pareho lang naman. Of course, lalagyan yung text yung, kasi parang paper yan eh. So there will be discussion. Hindi pa pwede yung, please just don't send me a code and then yung output ganun lang. Yung case yung class, you have to discuss. It's, parang nagna-narrative kayo doon. It's just like you're creating a paper and then each of the code there, may output, di ba? Then you'll have to discuss that. Okay? may discussion dapat yun along each step of the way. Okay, so that anyone reading your paper will understand, ano nangyayari? Because you're explaining the output, whatever code that is, you're explaining the chart that you're going to put there. Okay. All right. So let me